Hello friends, in today's question, in the arrangement shown in the figure, so this is the figure, a wedge of mass M3, 3.45 kg is placed on the smooth horizontal surface. Small and light pulley is connected to the top edge as shown. A light flexible thread passes over the pulley. Two blocks having mass M1 and M2 is connected to the thread. M1 is a smooth horizontal surface and M2 rests on the inclined plane. So this is the wedge whose mass is M3 and they are connected with the M3 is having a pulley through which the pulleys M1 and M2 are connected. And the base length of the wedge is given 2 meter. So it means this is given as 2. Angle is given 37 degree. M2 is initially at the top edge of the wedge. So M2 is initially here. If the whole system is released from rest, calculate the velocity of wedge when M2 reaches its bottom and velocity of M2 at that instant, taking G as 10.10. First of all, let we assume that M1 is moving with an acceleration of A. We say that M1 is moving with the acceleration of A in the right direction, and because of that, what is going to happen? M2 will be moving downward, and because of combination of movement of M1 and M2, this wedge M3 will be moving towards left by, let us suppose, by acceleration of B. And we are supposed to find out first of all what will be the acceleration with which this M2 will be moving. Say that M1 is moving towards left with acceleration is equal to A1. So because of that, what is going to happen? There is a slack in the string which will be connected with the M1. Okay. So this will result in, let us call this as 1. There will be slack in the string 1, and that slack will be dependent upon A1, which will be dependent on A1, and let us call this as string 2. Mass M3 is moving towards right, sorry, here it will be towards right, and it will be left, towards left with acceleration B. So it means there will be string, there will be slack in the string, so there will be slack in string 2, which will be dependent upon A2, sorry, not A2, but acceleration is B. So it means the slack in the entire string will be combination of slack because of A and slack because of B. You can say that. Thus, the total slack on the entire string will be combination of slack due to A, slack due to A and B. So it means ideally, if there should not be any slack in the entire string, the acceleration of M2 should be equal to the acceleration of the A and A plus B. Okay, so if you want that slack should be 0 ideally. For slack to be 0, for slack to be 0 in the entire string, the acceleration of M2 will be equal to A plus B, and that will be in this direction. This will be A plus B. Okay, you can say A plus B should be the acceleration of M2. So this is the basic understanding of all the things with respect to the acceleration. In the next part, we are going to draw the free body diagram of each mass and try to find out what will be the relationship between various combinations. So we start with the free body diagram of the wedge, that is M3. Rather, let us start with M2. That will be much more easier, because then it will be easy to solve everything. So M2 is along the slope of the wedge, and it is moving with the acceleration of A plus B, and we are given this angle is of 37 degree. So this acceleration can be divided into two components. So this we are going to get as A plus B. This will be 37 because of alternate angles, A plus B cos of 37, and this will be A plus B sine of 37. And as it is moving downward, this is mass M2. There will be also an acceleration which will be acting in the opposite direction, that will be called as B. Okay. So so various forces that will be acting in the horizontal direction. So let me draw it again. Let us start with free body diagram of M1. So this is our mass M1. It will be having a tension T and M1G in the downward direction, and it is moving with acceleration A towards the right, and there will be normal because of the surface that will be acting in upward direction. Let us call this a normal as N1. As the motion is in the horizontal direction, so we consider the forces in the horizontal direction only. Okay, so for horizontal forces on M1, we can say that T will be equal to M1 A. Let us call this equation number 1. Okay. Next, we draw the free body diagram of the wedge, and which is having a mass M3. So this is the wedge, and here it is a pulley which is connected to the string, the tension T, and we are going to have tension T in this direction. Angle is given as 37 degree. So we can divide this tension in two parts. This will be called as T cos of 37 degree, and we get this as T sine of 37 degree. There will be normal because of mass M2 in this direction. Let us call this N2, and it can be also divided to two components. We are going to have, this will be our angle of 37 degree, so we are going to have N2 sine of 37, and this will be N2 cos of 37, and it is moving towards left with the acceleration of B. So once again, we find out the horizontal forces that are acting on the wedge. Okay. So we can say that for horizontal forces on M3, so first of all we define T minus T of cos 37 degree. This tension goes, and then there is a component of normal. Okay, then it will be plus N2 sine of 37, which will be producing acceleration of B, and that will be equal to, mass is given as M3, this will be M3 B. let us call this as equation 2. And next we draw the free body diagram of mass M2. So mass M2 will be on the wedge angle of 37 degree, and let us suppose this is mass M2. Okay, it will be moving in this direction with the acceleration of a plus b. This acceleration can be divided horizontal as well as vertical. This angle will be 37. We get a plus b cos of 37, and this will be a plus b so this is a free body diagram for mass M2. So this is a wedge, and let us represent M2 as a dot. So it is moving along the inclined plane with the acceleration of a plus b. So two components will be a plus b cos of 37 and a plus b sine of 37. And it is also having an acceleration in the direction b. Okay, so we can write the horizontal forces on M2, and it will be also having M2 in the downward direction, M2G, and this is our M2. So we can say for horizontal forces on M2, I think I forgot something, or everything is done. Yeah, I forgot one thing, that is the tension. M2 is connected with the string, and this will be tension T, and this can be also divided into two components. Okay, so we get T sine of 37, and this we get T cos of 37. This will be angle 37. I think now it is done. Yeah, string, weight and acceleration. Yeah, that's complete. So horizontal forces on M2, so we can write this as normal is left, so we are going to M2, and this M2, let me represent here in this direction, will be N2. So there will be two components of N2. Okay, this will be our N2 cos of 37, and this component will be N2 sine of 37. Sorry for the confusion. So now we can write it as for all the forces, horizontal forces on M2, you can say N2 sine of theta, sine of 37 rather, minus T cos of 37 will be equal to M2, and we have this as net acceleration will be a plus b cos of 37 and minus b. Okay, so we can write this as M2 into a plus b cos of 37 minus b. this can be solved as, you can further simplify this part. So we can write n2 sine of 37 minus t cos of 37 will be equal to m2. If you put value of cos of 37, we can write this as 4 upon 5a minus 1 upon 5b. And let us call this equation number 3. And now the vertical forces on M2 for vertical forces on M2, okay, we get downward direction M2G minus N2 cos of 37, and we have plus T sine of T sine of 37, and the acceleration will be equal to m2 a plus b sine of 37. Okay, yeah, that's correct. You put the value of sine of 37, we can write this equation as m2g minus n2 cos of 37 minus t sine of 37 is equal to m2 a plus b 3 by 5, and let us call this equation 4. Next, we are going to solve these 4 equations. You can say that from equation 1, 2, 3 and 4, we get A is equal to 3 meter per second square and B is equal to 2 meter per second square. So these are the respective acceleration of M1, mass M1 and the wedge. Okay. And the next, we already know, or rather it is given, that for the wedge, this angle is 37 and it is given as 2. So we can find out this height. Let us call this as h. Okay. So for the wedge, h is equal to 2 tangent of 37 degree. So h will be coming as equal to 1.5 meter. Okay. So in the next part, we are going to consider vertical motion of consider vertical motion of M2. So considering vertical motion of M2, okay, and it is given the question that it starts from the top. Okay, it's given that it starts from the top and to the bottom. So vertical distance traveled by the mass M2 will be 1.5. Okay, so we can say that So vertical distance traveled by m2 will be equal to 1.5 meter, and it is also given that everything starts from the rest. Okay, if we start from rest, we can say that initial velocity will be equal to 0. Initial velocity of m2 will be equal to 0, and its acceleration let us represent it by capital A, will be equal to, we are talking about the vertical part, so this will be 3 upon 5 A plus B, or we can say that A can be written as 3 meter per second square. Okay, and this, remember, is the vertical acceleration. Capital A is vertical acceleration. So we are going to use the formula for the kinematics, which states that S is equal to ut plus half at square. Initial velocity is 0, so this components become 0, and S is given as 1.5. So from here we put the values, we get 1.5, A is equal to 1.2, A is given as 3, and t square. So from this we can say that t will be equal to 1 second. Okay, it's given that t is equal to 1 second. So it means in time t, the m2 travels from top to bottom. Okay, so we can say that thus in time t is equal to 1 second, mass m2 starts from the top and reaches the bottom of the wedge. In the next part, we are going to find out what will be the horizontal component of velocity of the m2. Okay, so it means at instant t is equal to 1 second. So we can say that at this instant means t is equal to 1 second, horizontal component of velocity, horizontal component of velocity of mass m2, let us represent it by v2, and in x direction, so we can say that this will be equal to, we can use the formula as v is equal to u plus at. Initial velocity is 0, so this component becomes 0, so we can directly write u to x and the horizontal component of the acceleration. Okay, so the horizontal component of acceleration is given as 4 upon 5 a minus 1 upon 5 b into t. Okay, where this is, let us write it x, it's much more convenient. So putting the value of t as 1 second and substituting value of a and b, we can say that v to x will be equal to 2 meter per second. And similarly, we can find out the vertical component. Similarly, v to y will be equal to, same formula, initial velocity once again 0, and this will be v to y is equal to the vertical component, that is 5 a plus b into t. So this implies that putting the value, we get v to y is equal to 3 meter per second. Now we have both the velocity component v2x as well as v2y. Okay, so it means we have v2x, okay, and we have v2y. So the resulting component, let us call as v2, will be somewhere in this direction. So we can substitute v2 will be equal to v2x square plus v2y square root. Substitute the value, we get v2 as 4 plus 9 rather, square root, and this implies that v2 will be equal to square root of 13 meter per second. And last part is the velocity of the wedge at this instant. Okay, so we can set the velocity of the wedge at t is equal to 1 second. So once again we can use the formula v is equal to u plus at, and it starts from the rest, so v will be u will be 0. So we can find out velocity of wedge, and let us suppose it is represented by velocity of the wedge was given as m3. Yeah, let us call it as v3. So v3 is equal to a3, okay, and a3 into t, and a3 is nothing but v. So v3 and t is equal to 1 second. We put both the values, we get v3 is equal to 2 meter per second. So we found out what is the velocity of the wedge at the instant, and we also find out what will be the velocity of wedge when m2 reaches bottom. Okay. This completes the question. Thank you.